I am assuming you already have downloaded the data on mortality in the United States from 1919 to 2020. We already have that data with us as a text file. We will start with Microsoft Excel. In this video, we are going to try to import the text file in Excel, and are going to make the data fit to be able to forecast. Per se, Microsoft Excel is not a great tool for time series forecasting. It has huge number of limitations, and maybe R or Python would be a better bet. But again, that be steep learning curve for some of you starting from scratch and learning R. So we are going to work in Excel, use some external tools. So what we need here is an updated package. Okay, so we need to have, if you look on the top, the data ribbon, I need this data tab. And the data tab should have this the method of getting data. If you don't have this, a simple way is to look for videos on YouTube on how to get the data tab. Even old Excel, you can import plugins or add-ins and get this data tab, or ways to import text and web data. And again, if you want to explore, there are videos on how to use this get data functionality in the new Excel beautifully. You can get data from web without having to type it out, get data from PDF. These tools are amazing. But again, I'm not, so I go to get data from text, and this is the data that I've downloaded, 99 to 2000. I double click that data. It takes a little bit of time to load, and the basic is it loads the data, but I see the columns are not separated. I have one column of the month, and everything else is in one other column. I cannot use it like that. So what I'm going to do is try to change my delimiters. I can change it from colon, comma, or custom it. But in this case, I know that my delimiter is space. It's space that, I know my delimiter is tabs. It's tabs that separates the different columns in my text file. So I select that, I get the different columns, and I load the data. I can actually load selective columns also. I don't want to load, but I'll do it in Excel. Once it takes a little bit of time, everything is loaded. I delete this notes column. We don't need it. I have two for month. And if you look here, I go to home. The format of this top center is date, which helps me. I don't need the month code because it's same data. And I also don't need population and crude rate. If I had yearly data, I would have got this information. But the CDC does not calculate or does not sort of extrapolate the monthly populations. Perfect. As soon as I have this data, my first step as soon as I have any data, is to plot it and see what happens. I select this data, go scroll up again and say insert a line chart. Here I have my deaths data. I put this data here, top, extend it so that I get a better view, use the entire real estate on my screen. Again, I get the data tab. I see there's a lot of vacant space at the bottom. I need to be able to see. So I go to format axis, 150,000. That's the minimum value that I can see approximately. It could be more, but that's fine. And yeah, so now I have a better view of my graph here. And yeah, I see two things. I see a certain peak. So let's see when the peak happens. This peak is on January. I have a peak. Again, 1st January 2001, I have a peak. 1st January 2002, I have a peak. 2003 January. So every January there is sort of a peak for some reason. More people are dying in January. Okay. And what I also observe is February there's a trough. So look at the data point. First, this is there's a trough here. Let's see the troughs. Yeah, it's 1st February 2005, 1st February 2006, 1st February 2007. There's a trough in February. Now what this is saying is that for some reason substantially lesser people are dying in February as compared to January. Now people dying less is always a good thing, but why should this happen? People die in January more, In March, again, it goes up. February, something happens and less people die. Think about it. If you want, pause your video and think about it a little bit. The simple answer here is that February has 28 days, while January and March have 31 days. So that inherently means that there should be approximately 10% less deaths in February as compared to January and March. Well, so now this actually essentially makes my data, it creates a pattern in my data which is not necessarily, which makes it slightly less forecastable. So I need to get rid of that pattern, right? Now, this days of the month issue is always problematic when we have natural processes. For example, mortality, births, number of, when I have cows and I'm milking them, the milk given by cows or electricity used up by people, it is problematic. But in other processes like sales, manufacturing, it might not be as problematic because as it is, most salespeople and most professionals work to achieve their targets. So whatever their target, they're going to work in the last week and somehow achieve it. So it may not always be as problematic in those situations. But again, here we know it is. So what I'm going to do is I'm going to try and find out days of the month, divide the monthly days by days of the month, and then find out deaths per day, and see if I can get some kind of a better looking pattern. So I find the days in the month. That's what I try to find out. And to make our data visible, I select the first row and make wrap text and also center it. And we write the formula here. You could have done it manually, but that's too much effort. Equal to day EO month. I select the month, comma 0. Two parentheses need to be closed. Enter, and the same formula will be reflected in my entire column. And what you see here is automatically the second month, which is February, has 28 days. Even the leap year, which is in 2000, it's a leap year, February has been given 29 days, reduces my effort substantially. And so now I'm going to say deaths per day, which is just a simple division, deaths divided by days in the month. And I have deaths per day, and I'm going to try and plot it. So I select this column, press the control key, select the other column, and then go back to insert and my line chart. I have this chart here, which is deaths per day. Putting it here, extending it to get a better view, and again, better use of real estate always. The lowest point is something like, I'll put something like 5,500 roughly. So I select this axis and select axis options. The minimum is 5,500. Enter. So now you see that February, this is a much better looking chart with a seasonality. Somewhere in January again, I think. 1st of January, February, this is a peak, okay? So February has higher dates. This is February again. So Jan-Feb generally has higher deaths the first few months. The trough, there is a trough which is happening on 8th month, which I think is August. Again, August. Again, August. So there is some kind of seasonality where less people tend to die in August. But I know that this is the structure of my data. So I've used the days of the month to make the data a little bit more smoother and more forecastable. We also can use Box-Cox transformations. If you have your data and you want to see what that is, feel free to Google, and there are ways to be able to do Box-Cox easily, but we'll not get into that for our purpose. But we have made it suitable, more suitable to forecasting, and I know that there is some kind of seasonality. So you may see other videos on what methods to, but this shortlists the methods. So I know I need to have a method which takes seasonality into consideration. And I'm going to use those methods in the next video and try to fit a couple of methods to my past data and then use that to select my forecasting method.